This is section 4.6, rational functions. And the definition we've got right here, a rational function is represented by f of x equals p of x over q of x, where both the top and the bottom, p of x and q of x, are polynomials. They do have a restriction. Q of x cannot be equal to 0 because you cannot divide by 0. But that makes this a rational function. The domain of a rational function includes all real numbers except the solutions of the denominator. That means anything that would make that denominator equal 0 will not be in the domain. So if you were asked to find the domain, you set the bottom equal to 0 and solve. That's going to give us the restrictions. So let's see if we can get where we need to be. All right. So let's look at this example. Here is a rational function. And so we're going to take this denominator and set it equal to 0 and solve it. This gives us the restriction. That's the thing that x cannot be. So the domain is all reals except x equals 5. Or formally written, it might look like this. And it's read all x's such that x not equal to 5. So that's kind of a formal way to write it. All right. The restriction is also called the vertical asymptote. It's a boundary, and it cannot be crossed. It's like it's set in stone. So let's look at this, the concept of it. So here's our actual rational function. Maybe if we put that, I'll let you see that in yellow. Makes it a little brighter. And then this dotted line right here is the vertical asymptote. That's the restriction. X cannot be equal to 2. Here's your function. If x were equal to 2, that bottom would go to 0. All right? So that's kind of the idea of what it looks like. We also could have a horizontal asymptote. And it is, again, a boundary. Here's the boundary. Let's make that this little green dashed line. And here is our actual graph. And it's not going to go there. Now, horizontal asymptotes can be crossed. It's not all the time, and it's not all that often, but it can be. Vertical ones are not going to be crossed at all. So, that's the way those look. Now, let's talk about finding them. We talked about the vertical one and how we set the denominator equal to 0. The horizontal one, you have to look at the degree of the top and the degree of the bottom. Let's call the degree of the top n and the degree of the bottom m. All right, so let's think about it that way. If the degree of the numerator is less than the degree of the denominator, if n is less than m, then the horizontal asymptote is y equals 0. If the degree of the top equals the degree of the bottom, then y equals a over b, where a is the leading coefficient of the top and b is the leading coefficient of the denominator. If n is greater than m, the degree of the top is greater than the degree of the bottom, then there are no horizontal asymptotes. So you have 3 options for this horizontal asymptote, and we're going to do practice on all of that, so it'll be more familiar. All right, let's look at this example. All right, we have 3x over x plus 4, and we're asked to find vertical and horizontal asymptotes. All right. For the vertical one, we're going to take that x plus 4 and set it equal to 0. We'll take this bottom. we'll solve that. X equals a negative 4. That's the vertical asymptote. Okay, that's our restriction. For the horizontal asymptote, we want to look at the degrees. We need to find out what n is and what m is. Well, you want to look for the degree. There's an understood 1 there. There's an understood 1 there. So n is 1, m is 1. That gives me n equaling m. And remember, we said then it was y equals leading coefficient, which is 3, over leading coefficient, which is 1. So we have y equals 3 is our horizontal asymptote. So if we were going to graph these, if you had to graph this by hand, you would come over here to a graph and you would put in these two as dotted lines. So x equals negative 4. That would be right about here. And you would have x equals negative 4. And then at y equals 3, you would be up here. That would be y equals 3. Then you could go to your calculator, put y1, 3x divided by x plus 4, and then put in your pieces within those boundaries, and you would have something like that be your graph. All right, so you would use a combination of doing this part by hand, then using your calculator to sketch in the pieces. Let's do this one. On this one, it's not as easy, it's not as apparent to get the vertical asymptote, but we can still do that. All right, so we're going to go down here and take this and put it equal to 0. Factor it. So on this part, we have 2x plus 1 equals 0. 2x equals negative 1. X is negative 1/2. And on this one, we have x minus 3 is equal to 0. X equals 3. So we have two vertical asymptotes. So we would go over here, and at negative 1/2, we can put that in. And at 3, x equals 3, we have one here. All right. And remember that we said up here on the horizontal one, if the degree of the numerator is less than the denominator, then y equals 0. So is that what we have in this one? The degree of the top, let's put this here. So n equals 1, and m, the degree of the bottom, was x squared, so that's 2. So n is less than m, so y equals 0 is that one. And so it's going to be right on the x-axis. So we'll just put a dotted line around there. So those are our boundaries. All right. So then you would go to your calculator and put this in like this. Be sure that you put the entire top in a set of parentheses, the entire bottom in a set of parentheses. That's pretty important. All right, then we'd go to our calculator, we'd put that in, and we would get pieces that look something like this. And things are staying within the boundaries that we drew. Okay? All right, let's look at one more. All right. Vertical asymptote. We can say x plus 4 is equal to 0, so x is negative 4. We got that one. And horizontal asymptote, we've got n equals 2, m equals 1. That gives us n is greater than, n is greater than m, so there are no horizontal asymptotes. And if there are no horizontal asymptotes, but this is greater than this one by exactly 1, which is what we have, then we do have a slant asymptote. And with a slant asymptote, you actually have to do the division. We have to divide this into this. Now we can do this here with synthetic division. We can have, let's do 1 minus 5, what was that other number, 8, and we'll be dividing by -4. Let's see what we got. And when you're doing this division for the slant, you can ignore this last part. You're just worried about this because this comes out to be x minus 9. And so our slant asymptote is that line. It's a slanted line. So if we were going to do this in the calculator, you would put this in divided by this. You know that you have a slant asymptote at -4. Not a slant, sorry, vertical. And then we would have, what I would say to do would be to put it in like this. Put y1 like this. Go ahead and put y2 to be x minus 9. That's going to be your slant one. Let's go ahead and do that. So in y1, we'll have x squared minus 5x plus 8 divided by x plus 4. And in y2, we'll put x minus 9. All right. Let's hit a graph and see what we get. I think I had it on, probably had it on zoom 4. So let's do a zoom 6. Okay, and we're really getting just part of this graph. Here's our one asymptote. Over here is our -4. I think if we go, let's change this window a little bit. Let's make that -20, and let's go down on the y-min as well. We're still not seeing it. Let's see, I'm pretty sure we should see something. Let's try this. Okay, so here's our pieces. Let me get down here a little bit, and we'll bring that back up, and we'll get that picture. Okay, so let's make this a little bigger. So you can see on this graph, so 1, 2, 3, 4, here was our, this is x equals -4. This line is x minus 9. That's y equals x minus 9. So this is a boundary as well. And here are two pieces of our graph. And they're fitting in our boundaries. So that's the way that one would look. All right. So I think we are ready to look at problems. All right, the first one says determine whether this is a rational function. And remember that the top had to be a polynomial and the bottom had to be a polynomial. And that is fine for this one. That is the case here. So this, yes, it is. What is the domain? Select the correct choice. All right, so to find the domain, remember that we take the bottom and we set that equal to 0. And we solve that. And so this is our restriction. So right here we can say all x is such that x not equal to 9/8. We're going to put that right there. All right. Number 2. Now, at first glance, when you've been used to looking at rational functions where you have something over something, people want to say, no, this is not a rational function. But let's think about that we could write this as x squared minus x minus 2 over 1. And remember, a constant function could be, that is considered a polynomial as well. So this is going to be a rational function. And what is the domain? Well, if you're looking at this, there's not an x down here, so there's really no restrictions. It's defined for all values of x. There's no problem in that one. It doesn't really have an x in the denominator. All right, we're supposed to find the vertical and the horizontal asymptotes of this one. So for the vertical, we're going to take 3x plus 3, set it equal to 0. And then x is -1. And so they've got the x equals. You're just going to put the -1 in the box. For the horizontal, the degree of the top is 1. And the degree of the bottom is 1 also. So that has n equal to m. So we do y equals -6 over 3. So y equals 2. -2, sorry. That's our horizontal asymptote. Let's look at number 4. We're going to do the same thing. Let's take x squared minus 7 and set equal to 0. So x squared is equal to 7. If you solve that, you get x equals plus or minus the square root of 7. Now, when you put that in your box, they don't have this plus or minus thing, so we're going to put square root of 7, comma, minus square root of 7. Okay? All right. All right, let's do the horizontal, and we'll do the degree of the top is 0. The degree of the bottom is 2, so n is less than m, and remember that makes it y equal to 0. Okay. All right, so we're going to do the same thing on number 5. Okay, we've got to take, let's go over here a little bit. We'll take the bottom, set it equal to 0. We're going to factor that. So a 2x and an x. We need a 5 and a 1. We're trying to get 3 in the middle. So let's try that. To be 5, we need a minus 5 and a plus 1. All right, then we have 2x minus 5 equals 0. 2x equals 5. X equals 5 halves. That's one of ours. And then x equals -1. So in this box, you'll have 5 halves, comma, -1. The horizontal asymptote, degree of the top is 2. Degree of the bottom is 2. So with n equals m, you have y equals 3 over 2. You took the 3 coefficient and the 2, and so this would be the answer that goes here. Okay. All right. Let's look at number 6. All right. Vertical and horizontal asymptotes. Now, before we fill those in, if there is something that you could cancel out, you do that before you list the vertical asymptotes. All right, so now the only vertical asymptote is we have x minus 4 equals 0, so x equals 4. So that's the vertical asymptote. The horizontal, you've got the same degree on the top and the bottom. And so you've got y equals 1 over 1, which y equals 1 would be it. Okay? All right, number 7. The vertical asymptote, and at this point we should begin to be able to just say x equals -3. It's the vertical asymptote. The degree on the top is greater than the bottom, so we don't have a horizontal. We do have a slant, so we've got to do that division. So we've got a 1. We're missing an x term, so we'll have a 0, a -7. We had to put in a placeholder. We are dividing by -3. Come down, 1, -3, -3, and we get to stop. Remember, it doesn't matter what this is. So when this changes back into x's, we have x -3, and that is what goes in that box. Okay. All right, we've got another one of those. Vertical asymptote is x equals 3. Let's do the slant division part. So we've got 4, 5, 0, dividing by a +3, 4, 12, 17. We can stop, and so we've got 4x plus 17. Okay? All right, we've got 2 more questions, and these have to do with rational equations, and so we're going to work those a little bit. I'm going to need a little bit of room to do this one. All right. All right, so in this rational equation, we've got a lot of rational expressions, and we want to try to get rid of them so that we can work that as a plain equation. So what we want to think about is that when you have fractions, usually you've got to think of a common denominator. And I want you to think about, sometimes it's a little difficult for us to do that really with expressions rather than just numbers. But think about going through a buffet line and that you're really hungry, but you don't want to repeat anything. You want one of everything. So if we were going to go through this buffet line and we're going through and we come to the x thing, well, we want one of those for sure. We come to the x -5 thing, put that on the plate. Come to the x, nope, we already have that, we don't need that one. So this is my LCD, and I need to multiply each of these pieces by that LCD. So I'm going to write our problem down here. And I'm giving myself some room to go back in and multiply. Oops, I want to do that in red. Whoa, I do not know what that did. That was weird. Okay, and then I've got that here and here. All right, so and it's all over 1, so we can just do that. All right, so when we do that, we can see that x and that x mark out, that x -5 and that x -5 mark out, that x and that x. So when we did that, we've got all of the x terms, all of the denominators are gone. Let's go through and write what is left. All right, so we've got 60 times x -5 minus 60x equals 2 times x -5. All right, we want to do that distributing. We've got a plain old equation now. 60x minus 300 minus 60x equals 2x minus 10. We did all that distributing. Let me get a little bit more room here. All right, now we should notice that that 60x and that 60x canceled out. So we've got minus 300 equals 2x minus 10. Let's add 10 to both sides. I'll do that now. Alright, so we've got negative 290 equals 2x. Let's divide by 2. And our final answer, negative 145 equals x. So the key here was to figure out what our common denominator was, looking back at our original question, and multiply each of these terms by our common denominator. And when we do that, we'll come out with a plain equation, no rational expressions, and then we simply solve it. So we have one of those to do. All right, now this one is also a rational expressions in this equation, but what's different between this one and number 9? What's different? Here we had 3 terms, 2 on one side, 1 on the other. In this one we have 2 expressions, and because we have that, we can cross multiply. We can do this business, and that's going to get rid of our fractions. So we would have 6 times 1 minus x equals 5 times 5x minus 1. We'll do our distributing. We'll have 6 minus 6x equals 25x. Minus 5. Is that a... Hold on. When I did my little green arrows, I marked out where I couldn't see that that's a negative. Okay, so we'll just say that's a negative there. So that's, sorry, that's my problem. Negative 25x plus 5. All right. Now, let's add 25x to both sides so that we can get those together. And you're left with 6 plus 19x equals 5. And then let's subtract 6. 19x equals negative 1. And x equals negative 1 over 19. Alright, so our technique on this one was to do the cross multiplying because we had 2 equal fractions. Alright, I think that should get you through for 6.